How are we, my people? I hope we are doing well. As promised, this is the second part of 5.4, and the reason why I suspected there were definite integration problems in 5.4, because it's kind of a warm-up to the, basically, I guess word problems. But the whole idea of the net change theorem should not surprise us. And in fact, I kind of hinted at it, well, more than hinted at it, when we were discussing the why of the second fundamental theorem of calculus in the video a couple days ago. And that's this. If you are given a rate, and the example, which I'll reiterate, the example that I gave is, let's say that you are traveling, okay, at 60 miles per hour, okay? And let's say I graph that, okay? This is time, this is rate, or what we'll call velocity, okay? And let's say right there is 60. Let's say here's 1 hour, here's 2 hours, here's 3 hours, here's 4 hours. Now, if you were to actually, chart that as a constant, right? Let's say you got your cruise control on and there's no traffic. Basically, how far you have driven at 60 miles an hour is dependent upon the time, right? And if you wanted to graph it, let's say you traveled for 4 hours. I know that this area is rate times time. Rate is here, right? And time is here. So this area has to be the distance, right? Well, that principle holds even if it's not a geometric area, okay? Let's say that you are traveling, at, 5 p.m. to San Antonio. Well, the problem with that is that everybody else is traveling to San Antonio at that time, and you're not going to be able to maintain a constant. Velocity. And so instead of a constant velocity, you are going to have a variable velocity, okay? But just as the example above, the distance is still the area under the curve, okay? So if you can actually find a function which actually represents this variable velocity, then you basically have to integrate in order to accumulate, right, from 0 to 4. Because ultimately what you're doing, instead of one big multiplication problem, you are dealing with the sum of an infinite number of multiplication problems, where the height is v of t, whatever the value of the function is at that particular value, and the width is this infinitesimal width. And then you're going to sum up the infinite number of cross sections and accumulate them from 0 to 4, okay? So the net change theorem basically says that the integral, if you're taking the integral of a rate function, that the integral from a to b is the net change. Now the reason it's not the total change, let's say that for some odd reason you decided you wanted to go for a walk because COVID-19 has got you all stir crazy. But you walk up your street, okay? You walk up your street, and then you realize that there are a bunch of people, and you want to maintain social distancing. So you turn around and you start going the other way, right? Well, if you're measuring velocity, then marching one way is positive velocity. Marching the opposite way is negative velocity. You walk past your house the other direction and you run into another group of people and you want to maintain social distancing, so you turn around again and walk home. Okay? Now, if you were to actually find this area, the absolute value of that area, the absolute value of this area, and the absolute value of that area, you would have what is called total distance. If you were to simply integrate from A to B, you would actually only get the net. And if you left your, let's say that you leave your house right here on the road and you went this way and you went back that way and you went back that way, obviously the total distance is different from the displacement, which is the net distance. Okay? Are you anywhere different from where you started? No. So in this scenario, you would get, if you were to figure out a way to integrate that problem, your integral would be 0. Because the distance accumulated in a positive direction and the distance accumulated in a negative direction would cancel each other out, and you get a net change of 0. Okay? So we're going to go through a couple of problems, and I hope that even if this is a little bit fuzzy in your head right now, that going through these couple of examples will help us a little bit in terms of fleshing out our understanding. I know I don't do this very often in terms of having some prearranged problems, but I went ahead and just kind of cut and pasted a couple of these into a Word document so that it would be a little bit easier for us. Now, of course, it's not only just walking and driving and stuff like that. Anything that can be expressed as a rate can basically be accumulated by integration, and therefore you can arrive at a net change. So in this particular example, we have water leaking from a tank. So water leaks from a tank at a rate of 2 plus 5t liters per hour, where t is the number of hours after 7 a.m. How much water is lost between 9 and 11 a.m.? Okay. Well, first, there's the weirdness in this particular problem, that is the 3 different times, right? So just make sure that, if t is equal to 0 is 7 a.m., then t is equal to 2 is 9 a.m., and t is equal to 4 is 11 a.m. So that basically takes care of that. Now, if I want to know how much water is lost, I have the rate. And so let's go ahead and graph that. I mean, we can graph it. Let me go ahead and get a ruler real quick. And let's say we have, okay, so you have 2, and basically we won't put it on a scale, but basically we'll just pretend that whatever slope that I am representing with that particular pitch of a line is 5, okay? So there's 2, that's 5. So if this right here is 7, this right here is 9 a.m., which is of course t is equal to 2, and this right here is 11, which is t is equal to 4, the amount of water lost is the area under that curve between those 2 times. So it's this area right here. Now, granted, you could actually do this geometrically, but let's go ahead and do it with calculus. Is basically the accumulation of all of the infinite number of cross sections between t is equal to 2 and t is equal to 4, given the rate of change 2 plus 5t dt. And as I integrate this, I'm going to get 2t plus 5 halves t squared, and I'm going to integrate that from 2 to 4. So when I plug this in, I'm going to get 8. And then, of course, when I plug it in and square it here, I'm going to get 16. 16 divided by 2 is 8. 8 times 5 is 40. And then I'm going to basically what you're doing here when you do the integral from 2 to 4 is you're doing the integral from 0 to 4 and then subtracting the 0 to 2, okay? So you would be getting this whole area in terms of doing it at 4, and then you're subtracting this area right here. So what happens here is when I plug in 2, I'm going to get 4, and when I plug in 2 here, 2 squared is 4, 5 halves of 4 is going to be 10. So I have 48 minus 14, so it is going to be 34 liters, okay? And so all it is you take the rate and you accumulate the rate times time, the infinite number of cross sections of rate times time. When you integrate that from 2 to 4, you will get the net change from 2 to 4, okay? Now, this is a pretty good problem down here because it actually distinguishes between displacement, which is net change distance, okay? So just remember that this means net change distance, okay? And this is total distance, which is different, okay? Now, in order to determine, because they actually can be the same thing, if over your interval the velocity never changes sign, if over your interval the velocity is always positive or the velocity is always negative, then displacement and total distance are exactly the same, okay? But we're going to have to figure out whether it does change sign. And of course, the only way to determine whether it does change sign is to try and figure out where this crosses the axis, where it has a 0. So that's our first order of business. And we're going to go ahead and let's 24t is equal to 0. And I factor out a t, and I get t squared minus 10t plus 24. And you get t and t minus 4 and t minus 6. Okay? Well, that's kind of interesting. That means that this right here changes sign at t is equal to 0. Well, if you're actually dealing with a real-world scenario, t is equal to 0 is when it starts. So now, of course, this cubic function has no bias against that. Only the setting of it in the real world does. And, of course, you're stopping your interval at 6. So the 0 that these two factors give us basically don't help us at all because those are the endpoints that we're working with anyway. But I do know that t is equal to 4 is going to be the place at which the velocity changes sign. Now, which way does it change sign? Well, when you have t is equal to 3, if I plug t is equal to 3 into here, I'm going to get 3 and negative 1 and negative 3. So I have a positive times a negative times a negative. So basically, if just in case you're curious, when t is less than 4, okay, v is positive. When t is greater than 4, v is negative. Now that's going to be a little bit helpful. But let's go ahead over here. Now this, of course, we only have to deal with this in terms of total distance. If we're just dealing with the net change, we don't really have to do that anything at all. We simply have to accumulate from 0 to 6 of t cubed minus 10t squared plus 24t dt, and this will tell us how far it is away from its starting point at t is equal to 6. It won't tell us how far it went, total distance. It'll simply tell us what the net change in distance is. So let's go ahead and do that. That's 1/4 t to the 4th minus 10/3 t cubed plus, of course, this is going to be 12t squared, and you go from 0 to 6. Well, it's a polynomial. You don't have to plug the 0 in. You simply have to plug the 6 in. Now, 6 to the 4th is not all that much fun. It's going to be 36 squared. So I guess you could, if you were trying to sort of make this a little more simple, you could factor out a t squared unless you have unless it's a calculator problem and you're dealing with it with your calculator, then it doesn't really matter. But since I've sort of put my calculator aside for right now, this becomes 36, and this basically is 6 squared, which is 36 divided by 4, which is 9. This is going to be 6, and the 6 and the 3 are going to cancel and make 2, so that's minus 20 plus 12. Well, this makes 21. This makes minus 20. So what's here in the parentheses is simply 1, and therefore the displacement is 36. What needs to happen over here, and I won't work it all the way out, but if I know that the velocity is positive between 0 and 4, then basically 0 to 4, and I'm thinking of this v of t right here, is going to give me a positive distance. From 4 to 6 is going to give me a negative distance, and in order to unnegativize it, technical term, we'll go ahead and plop a negative so that basically this negative distance flips positive again and doesn't take away from this, but actually adds to it. Okay? I'm going to go ahead and flip on over to another problem because I want to get to a few more things before we're done here. But this is an important principle, this is an important difference, because 36 is basically if this were a plus sign. The fact that it's a negative sign will unnegativize that negative accumulation and add it to the original 0 to 4 instead of taking away from it. Okay. Actually, I'll tell you what. Let's go ahead and I'll call it quits on this video, and I'll do a second video on net change. I just don't want the files to get too big or any one video to get too long. So go ahead and look for 2 videos on this, and of course we'll have further videos on virtual fourth. But I guess that'll be that. Take care, guys.